congruent. Opposite angles are congruent to each other. The diagonals, they're not necessarily congruent in a parallelogram. They're different sizes, but they do bisect each other. And then same side angles add to make 180. So for a rectangle, the same rules apply for a parallelogram, but there's two new things. Each corner represents 90 degrees, and then also the rectangle also has congruent diagonals. So from corner to corner, they are congruent. Today we're talking about rhombi. So they have all the same rules. Opposite sides are parallel, but now all four sides are the same. So using a colored pencil, we're going to mark that all four sides are the same. So I'm going to put 1 dash here, 1 dash here, 1 dash here, and 1 dash here. So if I knew one side was 5, automatically every other side on a rhombus would be also 5. This is the part that people forget the most, is diagonals are actually perpendicular. Does anybody remember what perpendicular means? They cross. And when they cross, what do they make? 90-degree angle. So perpendicular is technically a 90-degree angle. 90 degrees. The symbol for it is an upside down capital T. So using your pencil, we're going to draw in 90-degree angles at each intersection where the diagonals cross paths. So where my diagonals intersect makes a right angle. So you have a right angle in that small triangle. You have one in this small triangle, and this small triangle, which is kind of weird because now it looks like a square is in the center. But you need to know that the diagonals are making 90 degrees in each small triangle, okay? So you got 90, 90, 90, 90 automatically. And then this is the other thing people have been trying to do this entire time. We've been trying to do like angle bisectors. This is your shape that's going to bisect the angles. So in the corners, yes, opposite angles are still congruent. Okay, so whatever this is, this would also be this. If I knew that they were 60 and it's actually making an angle bisector, what would each side be? 30. So this would be 30 degrees. This side would also be 30 degrees. So this time it's nice because they're splitting in half, which is what people were trying to do for the parallelograms. So you also have technically your diagonals bisect each other. So it's bisecting, cutting it in half, cutting it in half. The diagonals are not congruent necessarily, but they are for a square. So let's jump down to a square because we're doing both shapes today. So a square has all the properties of every single parallelogram, rectangle, and rhombi. So opposite sides are congruent. You should already know this. So we're going to mark the top matches the bottom, which matches the side, which matches the side. The diagonals are congruent, so the diagonals also bisect each other. And then the main thing I really want to put on our picture is that we have 90 degrees crisscrossing each other, so we still have that right angle in the center. And then the last thing I want to make sure that you know is that the angles are still bisecting in the corners. So how much is a corner of a square? 90. So if I bisect 90, how much is each side? 45. So 45 can go here and 45 can go on the other side because together they make 90. Okay, so let's go to our paper. So on today's paper for rhombuses or rhombi, we're going to add in our new thing. So we have everything a parallelogram is technically plus 3 new things. We have 4 congruent sides. So like I said, if one side is 5, the rest are automatically 5. The other thing that people forget the most is the diagonals are perpendicular. So we have perpendicular or 90 degrees at the diagonals. And then the last thing is the thing that you guys have been trying to do for every single picture, which is make angle bisectors. Okay, so let's go to number 5. So take a second. Once you got 1, 2, and 3 added to your picture, go to number 5. You're going to put your numbers in your picture. So hopefully you have it somewhat labeled like this. So you have 34 here. This whole length is 38, so I just put 38 kind of off to the side. 34 degrees should be in this little corner because it says ZXY. So ZXY is half of it, so 34 can go here. So let's worry about the sides for now. If 34 is here, where else can 34 go? All the other sides. So you have 34 here, you have 34 here, you have 34 here. That's nice. Okay. If the whole thing is 38, if I cut it in half, because we're still bisecting the diagonals, what's 38 cut in half? So this piece is 19. This piece is 19. So let's worry about the sides first, and then we'll worry about the angle. So from W to Z, how much is that going to be? 34, that's easy because all the sides are the same. What about VY? 19, because I knew the whole thing was 38, I cut it in half. What about Z to V? Nope. Is there a number there? No. So this diagonal is longer than this diagonal. The diagonals are not congruent. So how could I find, if I'm trying to find Z to V, Pythagorean theorem? So I'm going to use a Pythagorean theorem anytime you're trying to find the side length of a triangle and you're like, this isn't a triangle. There's triangles inside this, and you have to remember that technically your diagonals are making 90 degrees. So we're going to make a triangle. Now we can either go to the top triangle, like to the left, or we can go down. I'm going to just do the bottom one just because it's like right here. So I have this triangle that I'm using. People still get confused at which one's A, B, and C. If it's connecting the 90-degree angle, that's going to be A and B. If it's not touching, that's going to be C. So in this case, C is going to be 34 for my Pythagorean theorem. So 34 is the hypotenuse. 19 is technically the bottom or the height, however you want to like look at it. And then I'm going to say I'm trying to find B. So this is one of the subtraction ones where you're doing 19 to the power of 2 plus B squared equals 34 squared. So when you do 19 squared, you're going to subtract it to both sides, and then you're going to square root it. So somebody with a calculator, what do we get? 28.2. Is that right? Yeah, that is right. Okay. So you should get 28.2. So 28.2 is not the whole length. It's just this piece right here. Okay. So 28.2 represents the height of my right triangle. So 28.2 goes here. So then what would Z to X make? 56 point part, because I would have to add it twice or multiply it by 2. So those are sides because they have 2 letters. Sides are the Pythagorean theorem. Now we're going to kind of like disregard everything we just wrote on here except for 34 degrees because we're looking at the inside of the triangle now. So we're looking at angles. So if I have 34 degrees here, where else can 34 degrees go? Z. Okay, so if I jump across the transversal, technically 34 can go here. So I have 34 degrees. That's what the bubble means. Where else can 34 degrees go? On the other side, because it's an angle bisector. So 34 can go here. Where else can 34 degrees go? On the other side over here, 34 degrees, okay? Because alternate interior angles say I can jump across the transversal, and I also know it's an angle bisector and opposite angles are congruent. So that's why they're next to each other and it jumps across, same thing, they're congruent. Okay, so let's see if that gives us enough. So WXZ is how much? 34. Because it's just talking about the middle letter, which is X. It doesn't want all of X, it just wants half of it. Okay, so what about WVZ? 90 because each corner is going to mean 90. And then ZYW. How can I find this corner right there? Perfect. So because I have 34 degrees, I have 90 degrees. I know a triangle needs to add to make 180 degrees. So if I subtract 90 and 34 from 180, how much is left over? D6. Okay. So if this is 56, what is X, Y, W? What would be right here? 56, because they're angle bisectors, so they're congruent to each other. So take a second. I want you to try number 4. Number 4 is just angles. So no Pythagorean theorem because that's sides. Try number 4. It's all angles. You want to find the measure of the angle. 38 can go in 3 other spots. So where else can 38 go? 3, 4, 5. Okay, 3, 4, 5. Which one would you automatically also know? The middle, because the middle is automatically 90. Okay, so we have 90 there. And then how could I find 6? And 6 would match with every other angle. Perfect, because a triangle has to add to make 180. So you're doing 38 plus 90 plus something, I'll just call it X, equals 180. So what's that missing angle to make a triangle? $52. So 52 goes here, 52 can go here, 52 can go here, and 52 can go here. Okay, we're gonna do one square problem on the back. So the front is all rhombi. On the back side is your squares mixed with rhombis or rhombuses. So we're gonna do let's do number 6. So number 6 gives us one piece of information, and based on that one piece of information, we're gonna find everything that goes along with it. So it says if ABCD is a square, AD is 11, we're going to find each missing value. So if AD is 11, I'm going to put that on my picture. Where else can 11 automatically go? BC, where else can it go? AC or AB and then DC because all the sides are congruent because it's a square. Okay. Automatically, what do I know about the corners? What's the corners going to be? 90. Okay, so each one of these is technically 90, right? So I have 90, 90, 90, 90. What's the center going to be? 90. Okay, so all of these, I'm not going to put a bunch of squares, but all of those are also 90 degrees. So you have 90 degrees in each corner, 90 degrees where the diagonals cross. Hi. Yeah, that's fine. Okay, so for B to C, what do we get? 11. How could I find A to C? Pythagorean theorem. So sometimes you're going to only use the small triangle in the center, okay? But because they use the whole distance, I have to use the whole thing. So I have to make a right triangle out of this line. I can either use the top half to make a triangle, or I can use the bottom half to make a triangle. Okay, sometimes you're just using the small triangles in the center. The reason why I'm using a big triangle this time is because it goes all the way across from A to C. Sometimes it stops at A to E, and then I would use one of the small ones in the center. This time I have to use the whole thing to go across. So I'm going to make it this side, but you could make it the top side. It technically doesn't matter. You're going to get the same answer. So is AC the hypotenuse, or is it going to be A or B? The hypotenuse. So I have to find C, and I'm using 11 squared plus 11 squared equals C squared. So 11 to the power 2 is 121. You're adding the same number twice, so you get 242. You're square rooting it to find C. So you should get 15.6. So 15.6 represents this whole length. The whole thing is 15.6. 15.6. So if that diagonal is 15.6, what would B to D be? 15.6, because the diagonals are congruent. So if the whole diagonal is 15.6, what would E to C be? 7.8, because you're cutting it in half. And then we're talking about the measures. So disregard your 11s, disregard your 15.6, because those are lengths. Now we're thinking about the corners. We're talking about the inside of a triangle. A triangle adds to make 180 degrees in total. So the first one says the measure of angle DA to B. So if I start at D, I go to A, and I end at B. That's talking about all of A. So how much is all of A? 90, because it's a complete corner. The next one says A to E to B. So how much is E? 90, because the diagonals crisscross, making 90 degrees in the center. What would C be D? 45, because it wants to know not all of B, but half of B, because it's cut across to D. So this side is 45 degrees. The other side is also 45 degrees because it's an angle bisector. So the last one says BA cutting across to C. What's going to be A? Is it 90 or 45? 45, because it's half C's. Okay, you're not skipping any. Let me know if it gets stuck. Like extra quiet today. Let me know if you need help.